So far, we defined exponents x to the m for all integers. But our definition varied depending on if m is positive, negative, or 0. We also saw the power rule that said x to the m to the n equals x to the m times n. Much like we used another power rule to define exponents for negative integers, we will use this to expand our definition of exponents to fractions. To start, let's try to figure out what x to the 1/2 should mean. For our power rule to hold, we would need x to the 1/2 squared to be x to the 2 times 1/2. But 2 times 1/2 is 1, so x to the 1/2 squared needs to be x to the 1, which is x. This means that x to the 1/2 is a number that when we square it, we get x. But this is something we learned before. A number that when we square it, we get x is the square root of x. So we can conclude that x to the 1/2 equals the square root of x. We can similarly do this for x to the 1/3, which when we raise to the 3rd power is going to be x to the 3 times 1/3, which again is x to the 1, which is x. This means that x to the 1/3 is a number that when we cube it, we get x. So similarly, we can conclude that x to the 1/3 is the cube root of x. And in general, x to the 1/n is a number that when we raise it to the nth power, we get x. In other words, for any integer n, x to the 1/n is the nth root of x. It's fun to remember here that when we started out inventing numbers, we started with the natural numbers, then included 0, then negative numbers. Next, we invented fractions of the form 1/n on our way to all fractions m/n. We are following the same progression with inventing exponents. And we just learned fractional exponents of the form x to the 1/n. Next, we will see how to have any fraction as an exponent. To do this, let's use our power rule. X to the 1/n to the m is x to the m times 1/n, which is x to the m/n. But on the other hand, x to the 1/n is the nth root of x. So we can conclude that for any numbers n and m, x to the m/n is the nth root of x raised to the m power. So we can now understand exponents for all fractions.